Howdy. I'm pretty honored to be here, actually, the last speaker. When I spoke in 2012, I was the last speaker on one of the sessions, and I brought up a nice big glass of beer that I drank while I gave my talk. I wasn't allowed to bring a big glass of beer up with me today. I know Sam Kotler, who spoke up here earlier, tried to bring his whiskey with him, and that didn't work either. I'm glad you're all here. This is a really big room, so I'm glad it's just you all that are here and not 1,700 people, because that would be pretty terrifying. Anyways, so I'm R. Tyler Croy. I've been involved in the Jenkins project for quite some time. I originally started helping out back when we were called something different, a name which I will not utter on stage up here. And I'm not really a Java developer. I'm an application developer by trade. I actually deploy a lot of my applications these days on top of the JVM. But Jenkins as a Java-based product, I didn't really have much to do as a non-Java developer. So I decided to help out with some of the infrastructure. There's a Puppet Jenkins module that got mentioned earlier today that I also maintain. And I've been trying to help out with the Jenkins project in ways that don't involve writing Java code. During the day, though, I work at a company called Lookout. Lookout is a mobile security company. Our primary products are on Android. We have an iOS product as well. But a lot of my involvement at Lookout is bridging the gap between application developers and the operations team. What I actually do is lead a team that's building tooling and infrastructure to help build out this fault-tolerant, service-oriented architecture that we're trying to build and put together for application teams. And that requires a lot of really close integrations with the operations org. I'm sure you're all familiar with Jenkins. If you're not, there's Wi-Fi. You can look it up. It's built in Java, as I mentioned, and it's been around for quite a while. I will go on record as saying it's the most popular open source continuous integration server on the planet, which is not an award anyone's actually given us, but I'm pretty sure that that's true. We have 900 some odd plugins. If there's something that you want to automate, Jenkins is a pretty damn good way to do it. And we use Puppet, and we've used Puppet for about 3 or 4 years now, but we didn't used to. So to sort of explain what modern Puppet is, at least for the Jenkins project, I've got to sort of go back in time to before when we were called the Jenkins project to what we used to do. And to explain what we used to do, I've got to kind of explain the project infrastructure itself. There's a lot of things that we run that make up the Jenkins project. And these are things like MirrorBrain for distributing binaries. We run some DNS servers, LDAP, a number of different web applications, whether they're Java-based or otherwise. And of course, some IRC robots that help us with some of our day-to-day tasks for contributors. The machines that we run it on, we're not really that big in terms of a deployment. I wish I could beat my chest and talk about how many nodes that we have deployed, but really it's a couple of physical machines, one's in Oregon, one's in St. Louis, and then a number of VMs in various data centers and various cloud providers spread across the US. And we don't really have any full-time contributors. There's a few folks like myself who I would consider part of the core owners group of the project's infrastructure, but our main gig is not maintaining the project's infrastructure. Kosuke Kawaguchi, who is the founder of the Jenkins project, he helps out a lot with the infrastructure, but his main gig is CTO for CloudBees. I work at Lookout building out this core infrastructure. None of us have the time to really spend babysitting this project's infrastructure. So to run it, we've got a lot of history. I want to go into sort of what we used to do and what was shitty about it. When we used to be part of Sun, and I say we, when Kosuke used to work at Sun, Hudson at the time, I said the name, the H word at the time, was a project that sort of grew organically. He had built the tool originally to run his tests before he committed because he kept committing shitty code. Now, this is a developer I highly respect, but he will commit shitty code, and Jenkins exists to help him not write that shitty code or prevent him from impacting others with some shitty code. And the infrastructure that we built up when Kosuke was at Sun was all scavenged. It was, we needed a new web machine. He would go find someone who had an extra machine sitting in a data center in Santa Clara or at some other Sun office, and they would light it up and give us some root access, and we would go tinker around with it until we had Jira up and running. And then we would forget what we did, no one would write anything down. No one could tell you what was actually done at any point in time on any of these machines. It was very, I wouldn't say ad hoc, but it was very unorganized and not a very good setup for us. When we left Sun Oracle, the mega corporation, I had come to know Puppet at that time. And so I had suggested, in my way, if any of you actually know me in person, I'm highly opinionated. And so when I suggested, I basically told Kosuke that we were going to use Puppet. And we started rolling out Masterless Puppet. And at this time, I was very new in the Puppet community. I didn't know a lot. I had never set up a Puppet Master before. I had never engaged in a Puppet Labs training session or gone to a Puppet camp, anything like that. And so a Puppet Master scared the hell out of me. So we rolled Masterless Puppet. It was something I could get. I understood it. You know, a cron would run on a machine and it would fetch some stuff, and then it would run Puppet apply, and that would all work. And we would get some of the benefits of Puppet of having all of our code going into Get. We would have semi-reproducible infrastructure, but not everything that we moved over became Puppetized, and some of it, even though it was Puppetized, wasn't really reproducible. As most things that a new person will create, the code is messy and awful, mostly because I didn't know any better. So I'm going to give you a link to this code later, and you can judge it and judge me as a result. So we switched this year, in April or May, we switched to Puppet Enterprise and a more master-oriented Puppet environment. And a lot of the things that we did gave us a much clearer separation of what modules were and what our code was going to be and how we would glue all of those things together. And we killed some of those snowflakes. We got things better puppetized and more reproducible, but we introduced a couple new ones. For example, if you asked me to stand up a new Puppet Master for the Jenkins project right now, I would probably be able to get it up after some tinkering. Standing up that first Puppet Master is sort of challenging. So I'm going to talk about what Puppet Enterprise actually is for us. Let me make sure. The reason that we actually ended up going with Puppet Enterprise, we've got a few number of nodes, so we're within the 10 license limit, which means we don't have to pay anything. So we get all this nice stuff for free, effectively, such as the reporting, whereas before with Masterless Puppet, we never really had an idea of what was running on any given machine at any given time. We would log into a machine over SSH and look at the last log that the Puppet apply had created. And if something looked right, then things were good. But otherwise, there was no centralized view on what our Puppet infrastructure was doing. We also got mcollective for free, which to date, I think I've used it to stop and start agents, and that's about it. But I've read good things about it on the internet, so I look forward to using it some more. One of the killer features, though, that I didn't realize existed when we signed up and said we're going to use Puppet Enterprise was this Debian and Yum repository for bootstrapping agents. Getting agents set up was actually something that I found very, very scary, something that I was going to be writing bash scripting to do. But Puppet Enterprise can act as a Yum repo or an apt repo, and you can just grab a Debian package to bootstrap a machine and sign your certificate and connect it to your Puppet Enterprise. The installer of Puppet Enterprise was also really, really easy to use. When one of the guys from Puppet Labs came to help us, we created the install file. Like, you can get a listing of all the selections that you made. I made sure to back that up. And in theory, I would be able to run through the installer again on a new machine, manually, of course, and get a similarly looking Puppet Enterprise setup going. I'm going to take this point to say, even though we are using the free version, I want to thank Puppet Labs a lot. Puppet Labs came and helped the Jenkins project. They donated some time and helped us get up and running with Puppet Enterprise and helped us develop some of the workflow that I'm going to talk about towards the middle of the talk. And if they wouldn't have come and helped us, we wouldn't have had nearly as much success automating some of the things that we have had this year. So right, modern Puppet, right? Let's look at some code. So the old Masterless Puppet was The word clusterfuck comes to mind. We've got 80 some odd manifest files in one repository. We have 0 tests, which is pretty embarrassing for a piece of software that people use around the world to test their own software. If you go to this repository, info-puppet, you can see all of our wonderful Puppet code that is pretty bad. We used librarian Puppet, which at the time, this was before R10K existed, at the time was the best solution above Git submodules for pulling in Puppet modules. And we managed all of our secrets by hand. The way that we used to manage secrets is Kosuke would send me a GPG encrypted email. I would save a GPG encrypted file. I would send whatever else I needed to send to other core members. I would send that to them in GPG as well. And we all just sort of had our shared sort of out of sync version of what secrets we needed to provision our production infrastructure with on our local machines. That was pretty bad. The code layout is interesting. I'll go with that. You'll notice, I mean, a gem file, Puppet file, that's sort of what you might expect. There's this confluence.deb directory with some code in it that may build you a Debian package for Confluence. There's features for ostensibly writing Cucumber tests for our Puppet, but we never really did it. We've got local modules, which is where we actually have stored all those 80 manifest files are in this local modules directory. And then we use some Ruby magic in the Puppet file to add local modules using the path syntax with librarian Puppet to actually install those modules for us. And then manifest contains all of these manifest files for each different kind of machine that we've got. You may notice a pattern that our machines are named after vegetables. This was another thing that I forcefully suggested because I wanted a good naming scheme, and vegetables was it. Our definition of module is also pretty shit. The way that we ended up developing a lot of Puppet was we would log into a machine and we would hack something together and call it a module once it finally got working. So if you go through some of our modules, you can kind of do some code archaeology and figure out what the hell someone was doing at a given time, because whatever's at the top of the file, they thought they needed to go there before they ran anything. And then as you get further down, you find all these additional hacks of like, oh, here's a file resource because I forgot that this thing needs a directory in this place, and oh, I need to run an exec script that's going to do an apt-get update after this other thing, and oh, I need to do this other thing. And you can go through sort of this descent into madness for a lot of our old Puppet modules because we didn't have a good way of testing or developing these things. And honestly, I didn't know any better to suggest otherwise. Our testing was also pretty much a joke. Our deployment, also a joke. Our run.sh script, which you may have seen in the directory structure, it more or less does this on every single node every 15 minutes, or it did this on every single node every 15 minutes. And if GitHub was down, well, that sucks. If the Forge was down, well, that sucks. And because we had no visibility, we would never get any report that a manifest was failing to apply until a community member came into IRC and said, hey, I thought you fixed this. I thought Apache was doing this thing the other way now. And then we, and usually me, would just have to go log into the machine and figure out what the hell was going on. And when I have to log into machines, it makes me very upset, especially when I've got other shit to do. And more often than not, I've got other shit to do than babysit the infrastructure that I sort of cobbled together. So we found a better way. And I say we there, and I don't mean the Jenkins project. I mean the Jenkins project and Puppet Labs, I think, have found a better way. When I was here in 2012 speaking at PuppetConf, I openly lamented the state of deployment and testing within the Puppet community. And fortunately, over the past 2 years, a lot has changed, and we're able to cobble some of the tools like R10K or RSpec Puppet or ServerSpec together to build a much better Puppet development and deployment and testing workflow. So the code layout of our repository is a bit different now. We still have this gem file and Puppet file. We've got this CI directory, which is new. We also have a dist directory, which is new. We have Hyra-data, which is way new. We didn't use any Hyra before. We have a manifest, and then the spec directory. And if you're a Ruby developer, the spec directory should look familiar to you. Our CI directory finally gave us the ability to codify some scripts that Jenkins would run to test our own Jenkins project infrastructure code. And it's really just a pattern that I actually really recommend if you want to reuse your Jenkins build scripts over and over for local development as well, is applying a similar pattern so you as a local developer can just run through a CI directory, execute all these scripts with bash, and be done with it. In our case, what these scripts do is use R10K to do a local deploy from the Puppet file, run Puppet lint, RSpec Puppet, and some other things to validate a particular build. The dist directory is something that's pretty interesting, and I didn't know about this pattern until Puppet Labs came to help us out. We've got some profiles and some roles. Now, before I had been introduced to this pattern, I threw everything into things that looked like modules and called it a day. And then my node declarations would be node, some server name, class, 1, 2, 3, 4, 5, 6, 7, 8, down to 10, maybe a couple file resources. And it was very, very difficult to test, but also it was not a very clean separations of concerns. My colleague Kosuke is a Java developer. He doesn't want to understand Puppet, but he has to work with it sometimes. And he would ask me, why do we have modules? Like, what is the point? This abstraction layer makes no sense. And looking at the way we used to use Puppet, I can completely empathize with his point because the difference between a node and a module was practically non-existent. We just threw shit wherever we thought it should go. But the profile and role approach means we've got these profiles that encapsulate very specific behavior on a machine. And a couple of these specific behaviors might be the archives profile. We don't run all of our releases through our mirroring network. We want to keep, it's something like 100 gigs of releases at this point, but we want to keep all these old releases around. So the code necessary to provision the archives server or that archives profile is all within this one Puppet manifest. And we've got a number of other manifests in there that represent different kinds of functionality. The accounts profile, for example, that's just included on any role that we need accounts on. The spec directory includes something, if you're using RSpec Puppet, is very, very familiar to you, spec classes, and then we've got profile and roles. But we also have this server directory in here. When we engage with Puppet Labs, one of the things that I grew frustrated with over the course of our working with them was they didn't have a testing story that made me happy. RSpec Puppet compiles a catalog. You can assert that a catalog does some things, and that's it. RSpec Puppet will not tell you that etc ssh sshd config has the right settings in it. It just won't. It'll tell you that the resources are there and that those might be run, but until you actually run that catalog on a machine, you're never going to know whether it's really doing what you expect it to do. And so we started playing around with ServerSpec and a plugin for Vagrant called Vagrant ServerSpec. And so we've committed all of these different ServerSpec files for each one of the kinds of machines that we have in production. So one such machine, Celery, is one of the machines that we have a couple of services running on. The ServerSpec code in the Celery directory will assert the actual state of what a Celery machine or what the Celery role should be. We also got a much better definition of what a module should really be. In our RSpec Puppet, we're no longer testing that every single module would install packages or anything like that. We're just making sure that we're including the right modules from Forge that are going to be doing the things that we expect them to do. I'm not testing the Puppet Labs Apache module. I'm just testing that when I compile a catalog, the Puppet Labs Apache module is in it, and then I'm trusting that that module from the Forge will actually test and do what it says it should do. Which also means that instead of those 80 some odd manifests that we had before, we really only have a couple modules that we need to maintain now. And one of these, the fork of the Docker module, that's just because I've been too lazy to work with Gareth to merge our changes back in. So we've got a groovy little fork of a module. IRC reported a little fork of a module. And then we actually refactored some of our code out from the previous incantation into a module itself. This was previously bundled into one of those big kludgy modules we had before. And we actually separated this out and reference it in R10K and pulled it down outside of our main repository. And that means I can accept contributions from anyone in this room or outside this room to any one of these modules, and we can improve that module together, but that doesn't necessarily mean that I've got to merge your code to be deployed on the production Jenkins project infrastructure. We also have much better secrets management now than we did before. We're using Hira to store all of our secrets with a very good tool called Hira eYAML. When Puppet Labs came in and we started talking about how we were going to manage these secrets, there's Hira GPG and Hira eYAML. And one of the sort of key differences, I think, of the Jenkins project and one of the goals that we had swayed our decision to move to Hira eYAML. All of our code, including the old shitty code and the new less shitty code, is publicly available on GitHub. Right now, you can go open issues and mock my terrible Puppet code while I'm standing up here because it's all available. And our Hira our Hira documents, I guess, are also all open. And the way that Hira eYAML works is you can encrypt lines or specific values inside of a Hira file. Whereas Hira GPG is the whole blob of your Hira file is encrypted. And so what this means is a few select members of the Jenkins community have access to the repository that has these keys. But when we change any of our secrets, say SSL certificates or Nick serve passwords that bots use, things like that, we send a pull request that's in the clear with encrypted values in it. And when I'm reviewing it, I'm not making sure that the pull request contains the right values, but anyone else can verify that what we're doing in that pull request, we're referencing the right Hira members, and we're pulling those in correctly and using them in the modules correctly. And with Hira GPG encrypting the whole file, you wouldn't be able to do that. So I'm actually extremely happy with the workflow that Hira eYAML has given us to where we can still use our code review and testing pipeline while maintaining, I would say, top secrets in the clear on GitHub. Testing is the biggest change that I think we made, and the one that I'm most excited about, and I want to talk now and after if you've got questions about it. Testing is where I'm really passionate. When I spoke at PuppetConf in 2012, I was lamenting how poor testing in Puppet was, and I almost felt like at times I would talk to people and say, testing in Puppet's really shitty, huh? And they go, yeah, well, okay, and that was it. And now I think we actually have the tool chain to start treating our infrastructure that is code as legitimately testable, reproducible, deployable code that we didn't have a couple years ago. So we're using RSpec Puppet, and as I mentioned, ServerSpec and Vagrant ServerSpec. And because we're using a masterful Puppet setup now, sometimes we'll still do a Puppet agent-t on a machine just as a final sanity check, but that's not required for our deployment flow anymore. Sometimes I do it just to make sure that everyone's behaving correctly, but it's not required. So I was talking about this archives profile earlier, and here's an example of some of our RSpec Puppet for this. You'll notice there's a couple things that are interesting here. We're a Debian group, or shop, I guess, so everything that we're going to be working with is going to be working under the Debian, the Debian version of some of these modules. And all of our RSpec Puppet is just testing that we're including the right stuff. We're including the class Apache, and I'm trusting Puppet Labs Apache to be doing the right thing. I'm not testing that my catalog contains package HTTPD or file, et cetera, Apache, sites enabled, et cetera, et cetera, et cetera. When we include the Apache module, I'm trusting that Apache is doing, or the Apache module is doing the right thing. And then other things that I might have custom on top of that use of the Puppet Labs Apache module, like enabling the bandwidth module, that I would test in my RSpec Puppet. And so instead of needing to test that everything is in the catalog, I'm just testing the stuff that I'm bringing in is there, and it's in the right configuration. Our Vagrant and ServerSpec stuff relies very heavily on some lesser used features, I'll say, of Vagrant. There's this notion of provisioners in Vagrant. The Puppet apply or the Puppet agent provisioner are one of them, but there's also a Vagrant ServerSpec plugin which provides a ServerSpec provisioner. There's also a shell provisioner, which you can just execute some arbitrary shell code when you provision a machine. But what not a lot of people understand, I think, is that these can be chained together. And so our Vagrant file will actually run through 3 provisioners. We'll run through a shell provisioner to make sure that the host name and things like that are set up correctly. And then we'll run through the Puppet provisioner to make sure that we're provisioning the machine correctly. And finally, we run through the server spec specific to that machine. And we also, because Vagrant uses Vagrant files, which are also just Ruby, we rely on that fact quite a bit in sort of dynamically registering nodes or dynamically creating nodes in the Vagrant configuration. So if I go in and I create a new role that's eggplant, actually eggplant's already existing, I don't know, new vegetable. If I go in and I create new vegetable, then if I did a Vagrant status immediately after that, I'll see a node that I can provision called new vegetable. And so we're really taking advantage of some of the lesser used features of Vagrant for some of this. And so here's the server spec file that we've got. And it's fairly straightforward. At least I think it's fairly straightforward, but I'm a Ruby developer, so what the hell do I know? We're describing a machine, in this case, spinach. And we're using this RSpec specific syntax called it behaves like. We've defined elsewhere in the project what our server spec for a standard Linux machine is. And that's going to be making sure that we've got our core users on each machine, that we've locked down password SSH authentication. And now every new machine that I add, all I need to do to add the sort of basic level of server spec is say, it behaves like a standard Linux machine. We run a couple DNS servers, so we also have shared examples for our DNS servers. And we say, it behaves like a DNS server. I think that's fairly straightforward to anyone coming into the project to understand what we actually are trying to test here. But this machine spinach also has some other specifics to it. We need to make sure that Groovy, which is a JVM-based language which we use for some of our scripting, is also installed on the machine. And so what I'm actually testing, even though we do have the Puppet Groovy module, which has our spec Puppet, and make sure that all the right resources, the file resources, et cetera, are in the catalog, I actually want to make sure that those files are on the machine. And the reason I need to make sure that those files are on the machine is because if they're not there, a whole lot of stuff that's been built on top of the assumption that Groovy will be available on the machine will start to break, and it will lead me on a wild goose chase until I find a Puppet catalog run failed, and we don't have Groovy. So when we run, we're using Vagrant AWS, which is another Vagrant plugin, quite a bit, because I've got this nice old ThinkPad here where I can't run too many virtual boxes, so I just kick everything off to EC2. It'll run through the shell provisioner, it'll run through the Puppet provisioner, and then the server spec provisioner gives you a nice RSpec style output of what's being asserted on the machine. We haven't extended this yet to run server spec on our production nodes to give us a sense of whether things are actually being laid down on a production node correctly, but this does at least tell me when I provision with the role spinach, the things that I expect to be provisioned on the machine will be provisioned, and I can reasonably trust that Puppet will do the exact same thing for the exact same role when we deploy it to production. So deployment is my favorite part. The deployment of the Jenkins project infrastructure is much more intertwined with GitHub and Jenkins than I would have ever imagined we would get to. Right now, if any one of you wants to make a change to the Jenkins project infrastructure, you can create a pull request. When that pull request gets created, we're going to go run those CI scripts, and it's going to validate that that pull request passes the scripts, or passes those tests. If it does pass the test, we get a little green check mark on the pull request, and someone like me can merge it to the staging branch. We're also using a tool called R10K Webhook. We pulled some of Phil Zimmerman's work into the Jenkins infrastructure project itself. And so when I merge that change into the staging branch, we're going to ping the Puppet master. It's going to do an R10K deploy of the staging environment, and immediately any node that's attached to that Puppet master is going to be able to provision with the staging environment, which I think is pretty cool. That means if I add an ad hoc node, I can go test it with the staging environment immediately. So we'll merge some of those changes in, and that'll all be going fine. And eventually, time permitting, someone will be able to merge those changes to production. We'll create another pull request, which will also kick off that same sort of CI flow to make sure that whatever compilation or composition of changes that we've got from the staging branch coming over to this production branch, it still passes all the tests and does the right thing. And then when we merge that to production, the R10 webhook coming from GitHub to the Puppet master R10 webhook will deploy the production environment. And when Puppet agents come to get their newly compiled catalogs, they'll get the latest code. And all of this happens in maybe 10, 15 minutes. Sometimes we'll kick agents manually. Most of the times, it doesn't really matter. And then those agents will report back to the Puppet master. And I referenced this Puppet IRC module that we were using that James Turnbull originally wrote. We're actually using a slight modification of that to report no-ops, changes, and failures into our IRC channel. So GitHub's reporting into IRC, and then the Puppet master reports into IRC, to where even the members of the community that don't have access to this Puppet master or the PE console can get feedback on what's actually happening when their changes get merged in and deployed into production. And all of this is right now available on GitHub. So I think that's pretty cool. I'm very, very happy about it. There's some other cool things that we did with this project, though, that aren't necessarily in the Puppet module and Puppet manifest testing and deployment side of things. We started to include Docker in our infrastructure. Like I mentioned, we have very few nodes. I think we have 8 actual physical and virtual assets running around. And all of these nodes do different things. Nothing in our infrastructure is single purpose. And so we started wrapping up some of these services in Docker containers so we could deploy those out to hardware. Bind was the obvious first choice. Bind is terrifying to me. I still don't trust it even in a Docker container. But we also Dockered up some other, I would say, security concerning services like our IRC bots and some custom code that we wrote. And when we pull this into the project's infrastructure, we make sure that the Dockerfile is very sort of simple. And the deployment of these Docker containers relies on the Puppet module code and the Puppet manifest doing the right thing and setting up the right things on the machine. And then the Dockerfile just trusts that it's going to be there. So you'll note that there's, et cetera, bind local. The Puppet manifest that's responsible, profile bind is what it's called, we'll make sure that that file or that directory is there and that the right configuration is in there. And then we also use Puppet to manage our Docker containers. So we only install and run our Docker containers when we've got that other code that's in place. So we're actually driving the deployment of these Docker containers and the configuration of these Docker containers from Puppet as well. But I think the quality that we've achieved is also pretty damn cool. We've got 20 some odd spec files, and there's a lot of tests in those spec files. There's an infinity% improvement over 0 tests, so I'm pretty happy with that. And less than 5% of our Puppet runs have failed since we switched to this workflow. We've been using this for about 4 or 5 months, and the majority of the test failures, as much as I love R10K, I'm going to throw it under the bus because it wasn't my fault. The majority of our test failures that we actually had were because we encountered a bug in a module, and then we couldn't roll back an environment. So for about a day or two, every Puppet run on a machine was just failing. And I would like to tell you how many Puppet runs were failing before in this old sort of hacked together setup, but I had no metrics, I have no reporting, I have no idea what the hell was going on before. So I'm assuming 100% of the Puppet runs used to fail, and now less than 5% do, so I think that's an improvement. All of our pull requests, as I mentioned, are tested before they're merged. So if we're concerned about the quality of Puppet code coming into our production infrastructure, the solution is not to lock down the ability to merge code. I think it's enable more people to write better tests or write better tests ourselves to give us higher quality or higher confidence in the quality of the code that's coming in. And since we've rolled this out, we've had many hundreds of successful builds coming into CI. This isn't just the master branch build. This is also the pull request. The quality of the pull request that we've been getting is also very high because we've got this tooling available for the development environment to test the Puppet code before it's even committed and created in a pull request. But there's some things that still suck, and boy howdy, do they suck. Testing with Puppet Enterprise is, I should have titled this differently. It's not testing with Puppet Enterprise. It's testing with a Puppet Master is still a huge pain in the ass. All of our Vagrant AWS ServerSpec stuff that's doing Masterless Puppet. And because it's really, really difficult to test with a Puppet Master, we decide not to use things like exported resources or anything that would require communication back and forth with the Puppet Master. The Chef community has this tool called Chef Zero, which they are using to some success to do integration testing with a in-memory Chef server. It would be great if something like that existed for Puppet Masters, but with the recent changes, who knows how that's going to work. If anyone here has a better way to test with Puppet Masters, please come find me after. We have lots of problems with Confluence and Jira. As much as I like their tools from a user standpoint, maintaining and automating these tools is nigh impossible. I was hoping we were just on old versions of Confluence and Jira, but it doesn't look like anything's gotten any better. There may be some people here that I have to buy a pony because they have some fledgling Jira modules that might meet some of our needs. But as it stands right now, our Jira and our Confluence installs are very unreproducible, which is a constant source of pain. OS upgrades are also a shit show. I actually, yesterday at the Puppet Contributor Summit, I had to upgrade a machine from Lucid to Precise, and I asked the Oregon State University Open Source Lab, which manages some of our VMs and physical hardware, I asked them just to pull the machine down, just spin me up a new one. I'm done dealing with OS upgrades. I want my infrastructure to be reproducible enough to where I can nuke the old thing, stand up the new one, and just provision on that. And that requires good automation, but also good backups that we could do recovery from. Doing a dist upgrade, or I don't remember what the Ubuntu apt command is, but it's pretty terrifying. We also have a big problem keeping up. And when I say we, I actually mean me. Most of the green resolutions of Jiras that you see in this chart are me going through on the weekends, periodically cleaning things. But you'll notice that the number of issues created is also going up. And this is not a quality metric. It's just we now have more and more contributors that are understanding that, hey, someone could change these things. These have been bugging me for 2 years. Tyler, go fix it. So we've made a lot of Jira changes. We've made a lot of other infrastructure changes with our mirrors. But the number of things that we want to accomplish as an infrastructure group has only gone up. And the number of contributors hasn't risen sort of in par with that. So here's where I start begging. Yeah. Everyone in this room and at PuppetConf can help with this. We're on IRC in this Jenkins infra channel. All of the code is up on GitHub. All the Docker containers, all the Hyra code, all our modules that we use. You can go look at our Puppet file. You can play around with the stupid Vagrant ServerSpec stuff that we're using. And if you have problems with it, you can also get in touch with us. I'm very, very happy that all of our infrastructure, sans secrets, is actually open source, and we can accept contributions from just about anyone with it. So that's about it. I don't want to get between anyone else and a drink. So if you've got questions, I'll be up here afterwards, and I'll also be at the party tonight. Thank you for listening, and please come help the Jenkins project. Thanks.
Thank you, R. Tyler Croy.